IPXers and to all the design engineers out here, you might know this is an aluminium electrolytic capacitor. Circular, known for one of the most spectacular fail modes in the whole history of capacitors. Let's go ahead and talk to YAGEO about a new development that they've got in aluminium electrolytic capacitors. And let me let you in on a secret, they're not going to be this shape anymore. Simon, thank you very much for having us at your booth at PCIM. Let's go ahead and talk about what it means to make a square electrolytic capacitor.
All right, well here we have our rectangular aluminum electrolytic capacitor. So, as you already mentioned, you can stack the round ones. And also when you start assembling them on a PCB, you have a lot of wasted space in the areas in between. So now, a lot of times space is very valuable these times. So you need to have a lot of capacitance in a small space, and you need to also get the heat out of those types of capacitors. Now, with the rectangular shape, you actually do get the heat out. You can have high ripple current capabilities, and better yet, you can stack and heat sink them. So as you start seeing this here with the nice shape, you can literally stack the other capacitor right on top and then have perfect heat transfer from one capacitor to the other capacitor. And then if you heat sink it, you have incredibly high ripple current capabilities on those products.
Absolutely. To all the engineers, if you're thinking about switching over your existing silicon to something new, a new substrate like a gallium nitrate or silicon carbide, why not compress your design more with a square capacitor? It's just raw extra energy density at the end of the day.
Yeah, so we have different types of technologies here. So if you look at this one over here, we have the rectangular aluminum polymers. So that allows you to have a much more compact package, and you have a different technology with the aluminum polymer. So here you have more ripple current capabilities, and you have also longer life. So whatever the application is, let's say it's a mild hybrid application in an automotive area, that's something that we see all the time. Now you want to have a lot of capacitance in that area, but you just don't have a lot of space. Cars are getting more electrified, meaning there's more electronics going in, meaning other stuff is going to run out of space. So just knowing that, you have an option and an alternative to just really rethink on how you can use an aluminum capacitor.
Amazing. I'm going to take the opportunity now to express this for everyone. Engineers, we want to know about the capacitance, we want to know about the temperature. Is there any disadvantage to using a square body form as to a cylinder?
Well, since this is kind of a new technology right now, the capacitance range is a little bit limited. So if you do still need large capacitance, right now you're just going to be limited to the rounder sizes.
Or extremely large.
But as we are growing, of course, scale of economy is always going to be true. So that means the more people are using these types of products, the more capacitance range we can offer. So that, I think, is really the only downturn right now, as the capacitance and voltage range is not quite there yet. But we can already go up to 500 volts in those capacitors, and we do have a capacitance range up to 330 microfarads. So again, it's coming and growing technology, so it's really cool.
Okay, let's talk about lifetime. How long can I expect this to last? Same as an electrolytic, the can style?
Yeah, so the aluminum electrolytics, they're going to have similar life expectancy as you would have with the regular can size. Now, with the aluminum polymer, they have a little bit of a different lifetime expectancy because there's no liquid electrolyte inside of them, right? Polymer is a solid, and with that, you can actually expect a significantly longer life than you would have with an aluminum electrolytic. The other benefit is also the temperature. With aluminum polymer, you can expect much higher operating temperatures. So, and with higher operating temperatures, you also get the longer life of those types of products. So aluminum polymer is really a great technology to consider when life, temperature really matter in the application.
Great. Right now, each one of you know that this is a through-hole package. You need to physically solder this in or use a machine, but what we really want to see is a surface mounted package. That means you can pick and place this. Simon, is that something that you are going to offer?
You know, you're not the only one that's looking for surface mount, so everybody's asking, and so we finally released the surface mount option for our aluminum electrolytic capacitors.
Oh, great.
You can see them right over here. We have the first off the production line samples right here in the case, surface mount rectangular aluminum capacitors. So you can see here, there's two of them on the board. It really is a very space-saving option, and the best part about it is when you mount them this way, you can also heat sink them into the PCB, so that again helps you with ripple current and extends the life of the product, because on the aluminum capacitors, it's really all about getting the heat out. So the more heat you get out, the more life and power you can handle on those capacitors. So
amazing. Engineers, this is huge. I didn't know that we would see the day where we have square electrolytic capacitors. Simon, thank you very much for running us through your range.
All right, good to see you.